Hi, everybody. So after I made that initial demo for you, I was kind of following the approach they took in the book, and I went to sleep after I posted that, and I thought, oh my gosh, that just seems so cumbersome. And when I woke up, I could just see what the easier way would look like. So this is what I'm presenting to you here with a simple demo problem. In this problem, I'm not going to focus on parsing because that's in another lecture, but I will show you the parsing, but we're mostly going to focus on calculations. So here's the problem. A researcher wanted to know whether women's happiness was impacted by relationship status, partnered versus single, and employment, career versus no career. And you can see that I've laid out the factors. I've laid out the populations. I've stated the hypotheses. And again, I have a different lecture going through this in more detail. And I've actually taken us far enough along so that I've looked up the cutoff points and indicated the comparison distribution. So we're moving right into step 4, calculating the sample F-score. And so these are the way your data are presented. I've tried to organize them so that it's pretty clear. You can see that each individual has a relationship status, either A, single, or 1, career. The numbers here, A and 1, to me, they seem really helpful in remembering whether I'm doing column data or row data. And as you know, the columns and rows are important in a factorial ANOVA. And then their happiness scores are all listed right here. And I've color coded the groups so you can see together all the people in condition B1, all the people in condition A2, all the people in condition A1, and all the people in condition B2. This will make it easier for us to do this work. So moving over to the right, basically this first table and the third table, you're going to want to present in your results. So this, when you run this in SPSS or PSPP, you're going to get a table that looks just like this. So we'll learn what this is and how we create it. And then up here is how we create our cell means and marginal means, and we'll use these for all of our calculations. And in fact, I think I'm even going to try harder to distinguish these cell means from the marginal means by, at one point I had color coded these marginal means. So I'm going to go over with you what these mean, what these means mean. And I want to just color these in a little bit differently so we can distinguish cells from marginal means. So first off, the cells are right here. Let's mark these with a border. I'm going to put a little heavier border around them so we can really see clearly what our cell means are as distinct from our marginal means. So let's put a nice border just around these cell means. So right in the center here are what we call the cells. It's this that we're going to use to make the graph at the end of our work. And so the cells just represent each of the 4 conditions. This is a 2x2 ANOVA. The cell that my cursor is over right now represents this condition A1, corresponding with these individuals. And of course, you can see what happens here. So the very first thing we're going to do is let's get these means posted in. So we need the average of the ones who are single and have a career. What is their average happiness level? And so let's get it. Type in equals average, and I can see because of the color coding, it's pretty easy to get those. So there we go. Let's get those for the single people who have no career. Single, no career right here. They're all pink, so I can easily get them. By the way, these little triangles in the upper corner means that Excel detects an anomaly. And in this case, it's detecting that we're not, probably detecting that we're not following a consistent, like we're not moving row by row, we're selecting non-contiguous cells. It doesn't like that. Let's get career partnered. If we really run into trouble where it's giving us a lot of errors and getting buggy, we have to go to this formulas bar and we can uncheck errors. And I can show you how to do that sometime if it interests you. So now we're going to go no career partnered, our last group. So now we've done just a really big thing right here. We can already look at these data and see whether we might have a relationship. And in fact, right now, using just these things, I'm going to create the graph which we need for our final result. So here we go. I'm going to select these categories. Notice I'm not selecting these. I'm not selecting these, just the headings for single, partnered, career, no career, and these cell means. So I'm going to now insert, and I'm just going to insert a bar chart, simple bar chart, 2D column. Here we are. We're all set. And so if we like the way this looks, if we want it to be distinguished between single and partnered, we can leave it this way. Maybe we think it's better to have it organized another way. So if we go into chart design, it's a little tab that pops up when you are selecting a table. If you select off the table, that goes away. So you have to select the table to see that. Then you'll get this chart design option and you can switch rows and columns. And I am going to, because this shows the interaction more clearly. It shows that blue is higher than orange in the career condition, but not the same in the no career condition. I'm just going to give this a quick title and I can put it right up there in my results page. Always number it. It's always a good idea. Graph, it's not a table. Graph. This way you can reference it if you decide you want to. And this is a common practice when you're writing about statistical results. So I'm just going to call it happiness levels by career and relationship status. Let's see if I missed any letters. That looks good. So now we can just take and drag this table right up here into the results. And so here we have a first step already done. Graph here, let's put it right there. Maybe I'll make it a little narrower, doesn't matter. That looks pretty good to me. All right, now we're ready to move on and we're going to get what we call our marginal means. So these gray columns refer to our marginal means. So we have to figure out the mean scores for people who are single, only the people who are single. Now, if you have equal cell sizes, meaning there's the same number in each group, like we have here, you can just get the mean of these two means. A better practice, because you won't likely always have equal cell sizes, is to get the average of those in that field. So just the single people in A, I can see them listed right here. I'm going to just grab the average from them, because if we don't have equal cell sizes, that's not going to work. I think I have this set to just one digit number. I'm just going to change this. You don't need to worry about it. I was trying to make a really simple problem with round numbers, so I had it set to 0 decimal places, but I'm going to change it to 1 so that the mean doesn't look so odd. Okay, now we've calculated the marginal mean for single people. Let's see what the marginal mean is for partnered people. And we see that it's 6.5. So those are our column means, our column marginal means. We'll be using these later. Let's now figure out our row means for career people. Let's get the average of those. Now, to get just the career people, they're not all in a row. What we do is we'll select these first 5 who are careers, and then let's just put a comma and select the next ones. And so there we go. We know that our mean there is a 7.9. And this is our row 1 mean. And our row 2 mean is, let's select the no career people, the pink. Here we go. And let's get a comma in there and select like this. And that works pretty well. And then this yellow special in the corner is our grand mean, which is the average of all of the scores. So let's calculate that one also. Here's the average of all of the scores, and that is our grand mean. And I think this probably looks pretty clear to you. We have our grand mean here, we have our row means here, and we have our column means here. So now we're ready for our next step, which is to calculate the denominator for our problem, the within subject variance. And this is a really familiar procedure to you. You know it well already, but we're going to calculate this for each individual cell. So we're going to first calculate for single career people, and our deviation then is going to rely on our score minus the cell linked to that category. So we're going to take each individual score. So we're going to go equals, and here's the score. And what we're subtracting isn't the grand mean or anything like that. We're subtracting the cell mean for that category. So let's hold on to that. I'm going to stabilize the row and column so we can rely on a little bit of copy paste. So now we have 0 because it is the same, essentially the same as the mean. And I have this formatted also, I think, for no decimal places. Let me change that here too. Just going to format the cells and add some decimal places so the data look a little more sensible to us. All right, there we go. There's the difference between our score and the cell mean, and I'm going to square it right away just to save time later when I do the copy paste. So we know this process well, the deviation and the squared deviation. So let's copy that down to those 5 individuals with a career. You'll notice I made the squared column a little bit lighter in font. I did that just because it's easy to miss track when you're trying to look at all of these. So now we can do the same process for the single with no career, which is this cell. So that's what we'll be subtracting. So let's take each score and subtract the single no career. Let's stabilize it, putting in a $sign. I'm going to put it in both row and column just in case. And since 5 is the mean, there's no difference there, but let's copy it down to these individuals who are in this category. Next, we're going to do partnered with career, which is this cell right here. So let's go equals. We'll take that score and let's subtract the partnered and let's put our $signs in. And here we go. The one looks right. Let's copy this down to those individuals. And let's continue on with this last category, the partnered no career equals that score minus the partnered no career, remembering to get the cell, not the marginal mean. And I'm going to preserve my formatting by copying it and just pasting the formula in using that FX box. Now that's weird. I must have done something wrong. I did. I forgot my $signs. So let's put those $signs in. Those static signs is how I think about them. And I'm going to redo that copy paste. And there we should go, but we didn't. Oh, there it is. Yeah, it was just a little bit sluggish. All right, so this right here is our very first sum of squares. Excuse me. So I'm going to pause this recording a sec because I want to have something in the boxes there. Okay, so as I said, we have just gotten our within subjects information, and this column, our sum of squares, is what we can put right here on our SS within. Instead of calculating it down here, let's put it right in the cell where we're going to need it. So we calculate sum of squares just as we always have done. We take the sum of the squared deviations. And that's going to be our sum of squares within. This tells us about the variance of this overall distribution. And our degrees of freedom within, you may recall that DF within is just equal to the, well, in this case, we'll just take the number of individuals minus the number of cells. That's a good way to think about it. So we'll take equals 20 minus 4, and we get 16. And that will be our degrees of freedom. And I'm going to pause again to take this call, my son. Okay, so DF within is just, let's just write it this way, the number, the total number, that uppercase N, minus the number of cells. You could also take each group, 5 in this first group, 5 minus 1 is 4. You could also do it that way, but this is an easy way to think about it. All right, so we've got already 2 cells filled in. We know that MS is just SS within divided by DF within. Let's get this capitalized. So we're all set with that too. In good shape. And let me capitalize that S as well. It likes to autocorrect there. All righty, so moving on, let's go ahead and get our total column. So our total deviation is just each score minus the grand mean. And remember, the grand mean is in that yellow box. So we're going to be subtracting this now from each score. Again, all we're trying to find out in these calculations is what does our distribution look like? So let's take each score, here's our 9, and let's subtract the grand mean. And let's stabilize it with dollar signs. There we go. And I'll square it right away before I copy. And now I can take and copy this all the way down. I'm going to do it the way I like to preserve my formatting, which is just to select the cells I want to paste it to and set them. Okay, and with that, we can find our total SS total. So SS total is just the sum. Oh, it's not very pretty. Let's get a capital X there. So our SS total equals the sum of X minus GM, and then we're squaring them. So that's the column we're going to grab. So let's get it. Equals the sum of all of these squared deviations. And our DF total is just the big N minus 1. Boy, I wish I could tell it not to lowercase that s. Our DF total is just the big N minus 1. So that's just going to be 19. All right, so now we're done with that. All we have to do is fill in these cells. So let's go ahead and get the between calculations for rows and columns. These are the between subjects or the numerators of our F ratio. So in order to do this, we have to go to this that we just filled in. And so mean column A minus GM, well, column A is this column. Here's the mean for column A, and we'll subtract our grand mean to get our deviation. So let's do that, equals mean minus grand mean. And I think that we'll leave it just like that. And we have to square it, of course. And then we need to put our n, and the n that we're referring to is the number in the column. And we know that the number in the column, all of these people, that's 10. And so we have to enter a 10 here. And we're going to need to do one more calculation with it. We're going to take this squared deviation and multiply it by this n. And that's what we would do if we did the other process. You'd see that these were all written out individually. But for this easier process, let's just take and multiply these together. There we go. Let's go ahead and get column B. So this is column B mean, these 10 individuals right here who are partnered. So let's get that score. So equals B minus our grand mean. We can go ahead and square it. And we can write our n in. We also have 10 in this group, and we can multiply them together to get the square deviation time n, which we're going to use in a formula. Next, we're going to get the mean of row 1 minus GM. Whoopsie, not that row 1. The mean of row 1, the career people, the 7.9, and subtract the grand mean. And we can square it. I'll just copy these over, in fact. We squared the deviation in this column. We just entered the n here, and we multiply these two together in this last column. And finally, let's get row 2 minus the grand mean. And we can copy and paste these. I'm going to copy and paste his formula just to preserve my formatting. All right, so now what we have here is what we add together in order to get SS columns and SS rows. So in order to get SS columns, we're just going to add together the deviation squared times n. So let's put that in there. SS between, let me put a space, there we go, then it'll keep that capital letter. And that equals, let's see here. We put it in, I could write it out as a big formula, but let's just write it using the way I've labeled that column. Deviation squared for column, let's see here. All right, first off, we're doing SS columns. It's easier to know the formula than to write them sometime. And if I wrote the whole formula, it would be confusing. So I'm just doing the last step. Is deviation squared for column, I'm just going to put A, column A, plus deviation squared for column B, and that's it. But let me write it, let me leave a space there. All right, so hopefully that makes sense to you, but either way, you can watch what we're doing. So SS columns, we're going to take these two scores and add them together. That's it. The degrees of freedom for columns and rows is just the number of columns minus 1. So let's go ahead, the number of columns. Well, we have 2 columns, so we have 1 degree of freedom. And it's good to get into the habit. We know that MS columns is just SS columns divided by DF columns, just to be specific. That same is true for rows, so I won't write it out separately. We know it's going to be the same number here, but that's what it is, and you should get in the habit of doing it. Okay, so we're ready with that. Let's get the main effect for our rows now. The main effect for career, and you can imagine what we're going to do. All we're going to do is sum up these two numbers. Our degrees of freedom, we have 2 rows minus 1 equals 1. And so we can use the same formula. We're just taking and dividing SS by degrees of freedom. We haven't yet calculated our F scores. Let's next figure out our interaction. Our interaction is sort of like the leftover variance that isn't explained by the main effects or the total effect or the within effects. The formula is, we're going to take our, I'll see if I can write it down here. SS interaction equals the sum of X minus GM, the grand mean, and we already calculated those. And from that, we're going to take and subtract X minus M for each score. And then we're going to subtract the category that the deviation for our columns. And then we're going to subtract our deviation for our rows. So I'll show you what it looks like in a minute here. Let's get M column minus GM. Notice we're not squaring these in this formula. And M rows minus GM. And then we're going to square all of that mess here. So we're not squaring at the beginning, we're squaring it at the end. So let's go ahead and prepare ourselves to do that. Now, I think it's going to be easier if we just paste in our column and row deviations. And so, for example, looking at where we're at, right now, let's get the columns for single people. So what is the deviation for column A? Well, it's 0.20. So I'm going to copy this and I'm going to paste it in all of these corresponding with group A. And I'm going to be careful to paste not the formula, but just the numbers. The way to do that is to select, first of all, select and copy, then select the cells you want to paste into, in this case, till the bottom of the single people, the end of the pink, then right-click and click on this with a 1, 2, 3 on it. That'll paste the values instead of pasting the entire formula, which will mess you up. Let's do the same for column B. All of these in column B, the partnered people, what numbers do we have for column B? The deviation's right here. So let's copy it and let's paste it in, but just as values so you don't get the formula in there. Next, we're going to do the same for the rows. So I see here that first we need row 1, these career people. Here's the number for row 1. I'm going to copy it and paste it in here as a value. And I see these people are also in row 1. So let me paste it in as a value also down there. And I'll grab it and continue to paste it as a value. And finally, let's get our no career people. So we're going to get our no career. We're looking at these calculations for rows and columns, as you can see. And let's paste this in as a value for the remaining individuals. Okay, now we're ready to do our interaction formula. So keep an eye on what this is. To get the score, we're going to type our equal sign, and all we have to do is start with our total deviation, which is right here for this person, for person 1, and subtract the deviation within, and subtract the column, and subtract the row. And we'll square it in a separate column. There we go. And now we can just copy paste this formula. We don't need to stabilize anything at all, nothing at all. So we can just go ahead and paste the formula. And we should have everything looking good. I think I'm going to change just to make sure we're seeing 2 decimal places so it doesn't look so weird. I was trying to get the simplest possible problem, but sometimes that can look a little deceptive. So this looks a little better, doesn't it? Okay, so our interaction sum of squares is right here. We're going to sum up this column right here. We can take a look and make sure we did it right. And it looks like we did it right. We didn't mistakenly get the squared column or anything like that. I can see the blue and the blue here indicate that we started with the total as we should have. So we're good. So let's go ahead and add that up. Here's our squared deviations. And of course, our degree of freedom for interactions. Let me write it down here. It is the number of cells minus the number of the DF columns minus DF rows minus 1. And in this case, we have 4 cells minus DF columns is 1, minus DF rows is 1, minus 1 means that we have 1 degree of freedom here. Our MS is, as we know, equal to the SS divided by DF. And we can also copy that right here. We're now ready to calculate our F ratios. So our F ratio is the same as before. It is just MS between divided by MS within. And let me capitalize and add a space there. And so we can go ahead and do that math. So we're going to take, this is our MS between. We're going to divide by MS within. We'll do the same here. And we'll do the same here. Now, terrific. We have our F scores. If we don't feel like rounding, we can, select these cells and ask, format them so that they're just 2 decimal places. Then, we can see them a little cleaner. All right. And this right here gives us all of our information. This is what the output file is going to look like if we do a statistical test. So we need two things up here where I'm going to be grading it. First off, we need all of this information, and this should fit nicely into right up here. So I'm going to click in the top here, right click, and just paste values. Then we won't have any messy calculations. So this looks good. It also reflects this graph. And then let's get the same information here. And then I'll talk to you about how we can make a decision and interpret this. So here we go. I'm going to just paste values. All right, we just did beautiful work here. I'm going to change the format of these cells so it's just showing 2 decimal places. Go clicking on number, and there we go. All right, so what we're doing now is we have that skewed distribution. We know the decision is simple to make. If our F score here is larger than this F alpha, we reject the null. So for main, and these are our main effects. So the columns represented relationship status. So our main effect for relationship is indicated here. So we can say that we have to fail to reject HO. Our F observed equals 0.52, which is not higher than, which is less than our F alpha. Now, by the way, you're not always going to have the same F alpha. We just have that because we have a 2x2 ANOVA. But if we had a 2x3, we would have different cutoff points for our rows and columns. Our main effect too, we have an F score of 18.58. In this case, we have to reject HO. I won't write any more. And for our interaction effect, we have a 6.32, which is also greater than our F alpha. So we have to reject HO. So how do we write our concluding statement? So first of all, we could say there was a main effect for relationship. Am I right about that? No, I'm not. Main effect for career, such that women with a career reported higher happiness levels. Now I can put the mean, M equals 9.6, than women without a career, maybe because of money issues. I don't know. These are just made up data. And let's put a M equals 5.0. Oh, that's right. Where did I get the 9.6? Let me just quickly change these to have more decimal places. Here we go. Let's make it 2 decimal places because that's what we need. Yeah, it's 8.8 should be here. I don't know where that 9.6 came from. 8.8 and a 5.00. And I'll follow the norm of 2 decimal places, even though they're zeros. All right. And then at the end of this 5.00, I can give the F value. I'll just put a semicolon and I'll write F. Now I'll write 1 comma 16 equals, and what was it? 18.58. And we don't have a specific P level. We'll just use the 0.05 that we tested that. We can write there was no main effect for relationship status. And I can just write F 116 equals 0.52. And interaction between relationship status and career was present. And now I'm going to try and describe that a little bit, such that women, let's see, now how should I describe it? Single women had greater happiness when they had a career than when they had no career. And I'm kind of describing the table backwards here. So I should have written this out in advance. I'm going to say the interaction was present, and I think I'm going to put the F score in here, and then I'm going to reverse the way I'm describing it. And so we had F with 1 and 16 equals 6.32, probability less than 0.05. And now I'll go ahead and describe it. But instead of describing it, since I have this organized by career in these bar clusters, I want to describe it according to the bar clusters first, even though I kind of like the way I was saying it. Let me just switch let me see what happens if I switch these around. Yeah, maybe I'm going to leave it this way because I think it's easier to describe in terms of single women. So single women had greater happiness when they had a career than when they had no career. Um, but the but partnered, I'm not sure I'm describing this well, but partnered women had a far less pronounced happiness level when they had, according to whether they had or didn't have a career. And it might be a good idea to put some means in here or something like that. For right now, I think I'm just going to leave it because I need to call my son back. But I hope you find this a much easier way to solve the problem because I'll tell you, I sure as heck found it easier. All right, thanks for tuning in.